Yeah, my name is Rachel, and I'm the co-founder of Solayer, which what we're building is a hardware-accelerated SVM network, SVM being Solana Virtual Machine. I guess maybe first is a little bit about myself to make this less boring. Grew up in the Bay Area, grew up in California, went to Berkeley, not super interesting, dropped out with Teal Fellowship. And my first entry point into crypto was with a decentralized exchange called SushiSwap, which is one of the first DEXs on Ethereum. Now maybe performing at over 300 billion in trading volume, and it's been live ever since 2020. That's kind of where DeFi kind of started. And for myself, I realized that a lot of the non-traditional paths I've taken is really in pursuit of what crypto's ethos is really for, which is freedom. So that's kind of, I guess why people are here, hopefully, is that in pursuit of decentralization and in pursuit of freedom in general. Okay. Okay. First of all, I don't know how well everybody knows what a blockchain is. So Bitcoin in 2009, came to be to become the first world ledger, that I call it, which you can't really do anything about it. You can't really compute. You can't really do math. They actually turned off the opcode so you cannot do math on Bitcoin. So essentially, it's a world ledger, so you can actually bookkeep, that's globally verifiable, globally live, 24/7, but you can only bookkeep. And then there's this world computer by Ethereum, where you can actually deploy smart contracts, you can actually compute the logic, you can actually do 1 + 1 = 2. And then we have Solana, which kind of positioned as the P2P global internet, which means you're not only able to compute what 1 + 1 is, you're actually able to compute very complex logic, very complex operations at a much, much faster speed. What makes blockchain special is also you have a world of very decentralized contributors around the world in different places, validating 24/7 to make sure that whatever you're seeing on the blockchain is correct and is not living in a centralized database like Facebook or Google. So I guess a lot of people may have, at least this is my theory of why blockchain even exists, right? So on the Genesis block of Bitcoin, it basically said the Times 3rd of January 2009, Chancellor of Brinks of second bailout for banks. And obviously, the moment was revolutionary in a sense that we need to call for a new form of banking system and a new form of system that you don't have to trust a government or trust the bank to deposit your money, withdraw your money, because ultimately they actually lose your money. So the evolution over the past 10+ years of what blockchain has evolved is peer-to-peer finance. So we had Bitcoin, and then we had Ethereum. You're now able to do swapping. You're now able to do lending, fully peer-to-peer, fully automated on a smart contract. And then you had peer-to-peer social. So Solana obviously has demonstrated that you're not only able to buy tokens, sell tokens, or trade, you can also deploy a lot of social components to what finance can provide. And personally, I think what blockchain really is built for is peer-to-peer humanity, is where you can actually operate with each other without a centralized entity and in pursuit of this concept of freedom. Especially in the world of AI and robotics, I think we're almost entering into this age of monopolization and machine-dominated, world. So I feel like crypto is the only industry where it's actually trying to not wipe out human race at this point. So how can you make a blockchain? How to make a blockchain actually the world of peer-to-peer humanity is, I think, just one concept is how can you make it fast? And that's kind of where Solana started, is high-performing blockchain design. A lot of vertical scaling, a lot of hardware acceleration. So fast is kind of the main component here. So what is Solana and what is SVM? Here are some basic stats of what it is. I think I maybe will touch on what makes Solana very special. Conceived in 2017 and launched in 2020, Solana is very much focused on vertical scaling. So there's horizontal scaling and there's vertical scaling, meaning that you're building a stack up to make sure it's fast. And they're investing a lot in hardware. So some examples why one mechanism is proof of history, which is a fairly new consensus mechanism compared to ETH or compared to proof of work, where you are actually building verifiable functions to create a historical stamp. So it's a lot more efficient because you now have ordering of your transactions instead of not knowing what exactly your transactions are. The second example is Solana has this thing called timeout. So the unconfirmed transactions actually get dropped if you're not confirming them. Other things like validators. On Ethereum is actually about $200 to run a validator. On Solana is about 15,000. So the validator infrastructure is actually quite high in order to actually become a Solana validator. So with all that being said, the biggest issue that we see in blockchain today and why Melania, Trump coin, they launched and then the entire chain crashed is because of bandwidth issue. And that's actually a physical issue that networks face. Not just Solana, is actually Ethereum, Bitcoin, like any type of blockchain today is because of bandwidth. So Solana validators currently already consume about 0.8 gigabyte per second. And the normal consumer grade internet is 1 gigabyte per second. So already we're seeing just one token launch or two token launch, and the rush, gold rush to get those things is already breaking the P2P consumer grade internet. So all that is to say, there is actually a physical bottleneck in which how much you can actually scale a blockchain. And what that leads to is validator propagation issue. There's connection drop. So the Melania launch, we had a lot of issues in terms of the outage. Sol price actually dropped $20 more than normal centralized exchanges. USDC also depegged by quite a lot, and there's a lot of liquidation because of the outage issue. But we're also realizing that right now is actually a pivotal moment to understand we just need a faster chain in order to even run a Binance grade order book style matching instead of things like AMMs, which is very old school and very inefficient, and that's kind of what I built for a long time too. Yeah, so I guess what we're building here is, in short, our goal is, Apple is essentially pioneering everything on chip. You want to do direct memory access, you want to build different types of logic directly on the hardware component itself. And what Solayer is really building is how can you accelerate real-time trading, how can you actually play Minecraft, how can you stream movies directly on the chip itself. So the entire blockchain is actually offloaded on different hardware components instead of writing more code or writing better code. So, I guess maybe a little bit context is that a lot of FireDancer, which is a very prominent player in the Solana ecosystem, is built by Jump. And Jump Capital is very, very well known for essentially jacking up their hardware to achieve nanosecond trading experiences across, globally from Asia all the way to Europe. Deploying things like shooting up radio signals up to the clouds to reflect back in milliseconds, or using glass so you can achieve similar to speed of light type of experience for trading, and all through hardware components. So we want to employ similar experiments and similar ideas, but offload different types of, or different stages of a blockchain onto specific components themselves. So number one is RDMA and InfiniBand. It is a little bit technical, but I'll try to make this very, very easy to understand. Remote direct memory access actually just means that you have memory that's from your, you have a physical a computer, and then you have to remember what it is, and you have to bypass the CPU and then load it on the chip. What we're actually doing here is completely remove that process, and you can directly process on the chip itself for memory and for input and output of software to physical device interaction, bypassing CPU completely. The second one is software-defined networking, which means we're actually utilizing control planes or actually utilizing physical cards that you can actually write software components and software logic on them. So you're not actually deploying on servers, but we're actually literally directly writing the logic of deduplication or scheduling or signature verification directly on the hardware component itself. The third one is multi-executor. So right now, you can think about Solana, Ethereum as like you have 1 million customers and you have 1,000 stores and you have one execution machine. And you basically have to wait for Walmart to actually finish processing transaction in order to finish processing my transaction at Target. So what we're doing here is you can spin up infinite quantity of execution machines. So Target has a machine or Walmart has a machine. And then it can check out separately without interfering with each other. And ultimately, it's connected via this high computing device called InfiniBand, which is actually used by NVIDIA to train AI computing distributedly. So the last one is we're also coming up with a different type of consensus that actually, so consensus is actually one of the biggest bottlenecks in terms of blockchain, right? Proof of stake, proof of work, the validators coming together to agree that this is actually correct transaction. Like that actually is the biggest bottleneck in terms of, or the biggest component that takes a lot of space up. So we're also coming up with a new consensus algorithm called proof of authority and proof of stake. So we ourselves run a very much we ourselves run a megaliter, and we essentially distribute batches of transactions towards a group of decentralized verifiers that require the proof of stake mechanism, and also with the mechanism to fall back on the consensus of Solana. So that's kind of the hardware stack that we're building. It is also the first ever blockchain to actually utilize, similar to Apple, is the first almost computer or the first company to really think about how do you offload software onto chips themselves. For us, we're basically thinking about how do you offload decentralized infrastructure directly on the chip to achieve 1 million TPS, to achieve 100 gigabyte per second experience. So you can actually build real-time order book matching and real-time streaming of movies. You can really only accelerate that with hardware. So we actually launched early this year. And so for us, we're going to build the infrastructure. We're also coming up with our own, we're also releasing our own flagship product. So the number one is SSOL and Mega Validator. We also run our own Mega Validator that does the that's doubling the compute unit, that's doubling the transaction processed, that's doubling the APY that's produced. And how we do that is essentially offloading onto the hardware through offloading signature verification, offloading scheduling directly on the hardware itself. The second one that we're introducing is SUSD and our payment infrastructure, where you can actually do real-time IRL payments directly on the chain itself. That's also earning on-chain yields. There's 2 more products in which we're building, so you can actually achieve the real-time trading experience once the chain, on the chain itself. So that itself is more of a later down the line type of thing. Okay, well, lastly, how we tie it all together is you cannot possibly run the world on Ethereum. I think we're seeing running one token launch on Solana is already troublesome. We are getting mass liquidations, and there's a lot of outage. So we basically need to build we need to find a very innovative way to actually achieve what crypto is all about, which is P2P finance, P2P social, and ultimately P2P humanity. So yeah, that's kind of very much what we're building, and hopefully you guys understand a little bit more about Solana, and yeah. So Firedancer have been building for 2 years. Their main component is offloading signature verification on FPGA, which is actually not that hard. Like it's very trivial. It doesn't actually optimize the network that much. It is an experiment that Jump is trying to do alongside their many other endeavors to offload trading experiences on like FPGA or like radio wave signals for trading. So the validator client itself is live in beta. I think about 2 to 3 projects have already been building, installing clients like that. So signature verification is a very small part of it. I would say like memory, input and output, and consensus are probably the biggest bandwidth consumption components for a blockchain.
I'll ask another one.
Okay.
Yeah.
Oh, coming.
Thanks for that presentation. What's the feasibility of doing this on other L1s?
Yeah, so we chose SVM very specifically because, first of all, on EVM, we want to create a very seamless experience with Solana. So users don't have to switch wallets. Users don't have to add a new chain ID because of their account creation process. You actually don't. So using our Infinity SVM is not decoupled from Solana. But EVM itself is, even if they build similar infrastructure with us, they would still have to switch the entire wallet. So as an EVM user, I have to download a new wallet, I have to add a new chain ID, I have to bridge it over. For us, is actually the users don't have to do anything. So I think user experience is what we're aiming for. Our approach to go-to-market is also not building like, let's give out a massive incentive for everybody to come over, but rather we will build our own infrastructure, which we've already released some, and the next one is essentially how do you actually build a real-time trading infrastructure that's order book based directly on the chain itself that can match real-time orders. Because ultimately, I think, for example, AMMs will actually not be the future of decentralized exchange. It will actually be order book to ultimately replace centralized exchanges like Binance or Coinbase. So you need a millisecond, like sub-millisecond block time infrastructure to achieve real-time order matching for order books. So we're a little bit different in terms of infrastructure and go-to-market approach. I think other chains, possibly they can do it, but EVM is more of a bottleneck in terms of the UX.
Sure, but the volume still, and aside from meme coins that trade in Solana, the volume of assets still in Ethereum, like RWA, if you look at the volume, like 90% in Ethereum, don't you think you're bottlenecking yourself by only attaching to Solana?
So maybe I think liquidity is a great metric. Personally, I see volume as probably the most important metric. So for DEXs, on the volumes on Solana is about 7 billion. Binance is at about, last time I checked, 30 billion. So it's actually catching up to how much volume centralized exchanges is performing just on Solana alone. I think liquidity is so having built an exchange before, liquidity is a great metric, but ultimately I think it is about volume that actually speaks for usage, speaks for user volume.
Yeah, but there is meme coin usage. Like that's like, so yeah, you're gonna get way more volume. So volume is not volume.
Yeah.
Let's be
Yeah.
clear here.
Maybe the goal here is also to add other EVM, move VM folks, but I think SVM is probably what we want to focus on for now.
Hi, Rachel. How are you guys accelerating the signature stuff? Is it via CPU SIMDs or GPUs or FPGAs?
FPGA. So we're also using things like RNIC for offloading memory, direct memory access, so people can actually directly access memory, directly access input and output on the card itself.
On the NIC card?
Yeah.
Ah, I see. Like Mellanox NIC cards?
Yeah, that's
Got it.
That's one that we'll use.
Okay. And what do you foresee that if validator running special exotic hardware to run the SVM, would that block access to some or make it high barrier to folks who would want to be validators? Because this will then make it expensive for validators to enter the market and become validators so that the network is more decentralized. Yeah.
Yeah, so because of the proof of stake and proof of, okay, I don't know. So because of the proof of authority and proof of stake architecture is a new type of consensus, we actually run our own mega leader, and then we batch the transactions into a group of verifiers through proof of stake. And the group, to become a verifier, it's actually less expensive than becoming a Solana validator. So I would say it might be cheaper to join our network than just running Solana validators. Yeah.
Any other questions? I actually have one for you. This is a little loaded, but yield is a very, very important part of most ecosystems on Web3. Can you talk about how incentives work and why it's really important?
Yeah. So the reason why we introduced SSOL and Solayer Sol, Solayer USD is any asset bridged over, or it's not bridging over, but any asset on us is completely yield bearing by nature, like under the hood. So you operating on a lending protocol or a trading protocol, under the hood you're actually earning RWA, so SUSD is powered by Treasury. You're earning 4 to 5% Treasury yield. SSOL is 13% to 18%. So you're actually completely, while you're using any sort of product, spending off-chain, trading, or just sitting in your wallet, you're actually just earning the 4%, the 18%, 13% yield on its own. So yield bearing is a very important component to DeFi and permissionless finance. So yeah, hopefully that answers the question.
Thank you. Any other questions for Rachel? Awesome. Well, thank you so much.